Hey, what's up? Leetcode 1320. Minimum distance to type a word using 2 fingers. You have a keyboard layout as shown in the XY plane where each English letter is located at some coordinates. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Alright, it's clearly just in order. Okay, yeah. Given the string word, return the minimum total distance to type such string using only 2 fingers. The distance between coordinates xi and x2, y2 is the absolute value of x1 minus x2 plus y1 minus y2, in other words, Manhattan distance. Note that the initial position of your 2 fingers are considered free, so do not count towards your total distance. Also, your 2 fingers do not have to start at the first letter or first 2 letters. All right, then. Okay. So, let's see. Now, one of the questions that I would have is, can your 2 fingers be at the same place at the same time? But in all fairness, I don't actually think that it would ever make sense to move into that position. So let's make a mapping here. So it's going to be what the hell is it going to be? Character to x comma y, right? So, I don't know, CHR of ORD of A plus I to, I don't know, I mod 5, no. I integer divide 5, I mod 5. So 0, 1, 2, 3, 4, oh shit. Uh, 0, 1, 2, 0, 1, 2, 3, 4, 5. Boom. Okay, yeah, like that. I think that looks good. Let's just do a quick sanity check here. Return 0. I is not defined. Oh dear Lord. Okay. So G is 1, 0. Yeah, it looks good to me. Z is 4, 1, so 0, 1, 2, 3, 4, and 1. So yeah, that sounds good. So I think position space should be like our default. There's no reason that your first finger can't start on the first character of the first word. It doesn't make any sense otherwise. But where we implement the second finger is not necessarily clear. So, when in doubt, use recursion. Now, there's only 26 times 26, well, I guess 26 times 25 possible first and second finger positions, maybe divided by 2 if you say that they're invertible. Let's just say not divided by 2. You know what? It doesn't matter which finger is which. So maybe we really should say divided by 2. That'll help us get to our base statement quicker. Okay. So we're going to say LRU cache none def R finger 1 finger 2 position I Okay, assert finger 1 is less than finger 2, right? And is that true? ORD of A, ORD of space. I'm going to work for that. All right. What is ORD of Z? CHR of 1 plus. Okay. Is okay. Yeah, so we'll say if I equals length of word, not words, word, then return 0. Okay, needed character equals word of I. Now, if F1 equals needed character, or F2 equals needed character, then return R of F1 comma F2 comma I plus 1. So, in other words, if our fingers are in the right place, then we don't need to don't need to move. So, from here, okay, we either need to move finger 1 or finger 2, right? So, use finger 1 equals, I don't know. Well, we'd have to move to the position, right? Yeah. Manhattan distance of tuple 1 comma tuple 2. So we'll say x1 comma y1 equals tuple 1, x2 comma y2, not t2, y2 equals tuple 2, and then return absolute value of x1 minus x2 plus absolute value of y1 minus y2. Just like that, trivial. Okay, so we are going to move finger 1. Yeah. So this is going to be Manhattan distance of m of f1 comma m of I guess needed character, right? Yeah, and then recursive, and then it's going to be min of needed character comma f2, and then max of needed character comma f2, and I plus 1. So that is our use finger 1 choice, right? Okay, and then we are going to have an extremely special case. How special do you want it? Let's just say m of, I don't know, that equals -1 comma -1. Yeah. So if x1 equals -1, then return 0. This is always the one that we're moving to, right? Just make it work both ways. Or x2 equals -1, then we return 0. because that is us not having placed it yet, which allows us to do this. We can just apply it directly. So we are moving finger 2. So Manhattan distance of finger 2 to needed character, and then its minimum of finger 1, which we are keeping in the needed character, and the max of finger 1 and the needed character. Okay, if we do it like this, then we should be able to pass in 2 blanks, right? Yeah. And that will result in the same recursive calls, so it's not gonna increase computational complexity. That's what the memoization is for. So just return minimum of use finger 1, comma, use finger 2. And I think it really is that simple. So just return R of 0. And let's see it blow up. Oh dear. Oh dear. Oh dear. Oh dear. Oh dear. I see what happened. Do you see what happened? You know what? I think this is actually just fine. So, all right, 3, 6. All right, beats 72.32%. That sounds pretty good to me. And I will see